The year is 2124. You wake up from your pod and step outside. The streets are eerily quiet until suddenly you hear a loud, jarring moo. It's the apocalypse and all the cows have gone completely mad. Thrilling as that was, our story doesn't quite start or go there. Let's take it back to 1986, when British farmers began noticing something odd about their cattle. These cows started acting aggressive and agitated, and then they began dying. It didn't stop at cows either. Humans who ate tainted beef products developed similar symptoms, resulting in an outbreak that garnered worldwide attention. We later learned that this illness was likely due to the herbivorous cows being fed feed made with other cows. This caused the spread of bovine spongiform encephalopathy, or mad cow disease. When transmitted to humans in the variant form of Creutzfeldt-Jakob disease, it can lead to dementia, psychosis, and death within a year of when symptoms first appear. Bovine spongiform encephalopathy and Creutzfeldt-Jakob disease are both types of prion diseases. But what is a prion? Is it a virus, bacteria, fungus? Is it all of the above? Well, no. Kind of. We'll get into that later. For now, just know that prions are proteins that have been misfolded. In normal cellular prion proteins, there are 3 alpha helices and 1 beta-pleated sheet, so more helices than sheets. However, with misfolded prion proteins, the conformational change causes there to be more sheets than helices, severely disrupting the protein structure. When prion proteins misfold, they like to make it everyone else's problem. When misfolded prions come into contact with normal ones, they trigger them to misfold as well, creating a domino effect. And clicky as they are, these misfolded proteins like to stick together in the brain, forming aggregates. In an infected brain, there are large aggregates and then there are small ones. Smaller aggregates may not look like much, but they're the dangerous ones. Due to their size, they're able to worm their way into cell membranes, drilling in holes that cause the brain tissue to degrade into a sponge-like texture, giving prion diseases their broader name, transmissible spongiform encephalopathies. But doesn't the self-templating nature of prions sound a little familiar to you? Doesn't it remind you a bit of viruses? Prions share several traits with viruses. They're both non-living infectious agents that are unable to reproduce on their own and can remain dormant in the body for a long time, allowing them to proliferate and spread. But unlike viruses, they have no genetic material and consist only of protein. Further, prion diseases are not just transmitted from person to person, or from cow to person. They can also be inherited genetically and can even occur sporadically. In fact, 90% of Creutzfeldt-Jakob disease cases do. And due to their structure, they're resistant to common sterilizers like heat, chemicals, and radiation, making them incredibly difficult to destroy. Sounds scary, I know, but there's no need to panic. Prion diseases are incredibly rare, with only 300 cases reported annually in the US. They are still quite mysterious to us, as we still don't fully understand how protein misfolding leads to neurodegeneration. But further research could help us unlock treatments not just for prion diseases, but also for Alzheimer's and Parkinson's, which actually share similar disease pathways to prions. And who knows? Perhaps we could also help rewrite the ending of the next apocalypse movie.